that question. Let's just finish it off. We're then asked about an interception. Okay, we have the ball being intercepted at peak height and with a velocity of 10.5. Okay, now the ball makes contact with a paddle, a racket, and we assume that the collision is elastic. Now, what does that mean? Elastic collision means, in this case, that the ball comes in with an initial velocity of u equals 10.5, and it bounces back with a final velocity of 10.5, but in the opposite direction. And again, this is a point that people forget, is the subsequent motion of the ball. All right. If we want to calculate the average force, we are going to use our relationship, our Newton's second law, which is that F times delta t, the impulse, is equal to the change in momentum, or in other words, the force is equal to the rate of change of momentum. Okay, so we're going to use delta p is equal to m times v minus u, v being the final velocity and the initial velocity here is u. And what we have to remember is that if v is, in my case, negative 10.5 because it's moving to the left, u is positive. And so we end up with our delta v being twice the value of that initial velocity. So we've got minus 10.5, minus 10.5, giving minus 21. We then multiply by the mass, which we're told a while ago, and we divide by our time delta t 0.01. And we end up with a force of around about 5.7 newtons. Okay, notice here I've kind of been a bit cheeky. I've forgotten about my minus signs there. Generally, that's just a directional thing. As long as you've remembered to include the change in direction, then you will get a value of 5.67, either positive or negative, and that doesn't matter in this case. So be aware, just read the question very carefully. If it's an elastic collision, then what you can assume, because that paddle is stationary, then you can assume that u and v are the same, they simply have opposite direction.